So thanks for joining us today to talk about continuous convergence. Whoa! So we're going to talk a little bit about what we call continuous convergence, which is really kind of an extension of something that's been going on in the application space for quite a long time, which is really continuous delivery for applications and for infrastructure, and kind of bringing the two together. So this is something we've been doing at GE Capital with the chef guys for a little while. So I'm Richard Nixon. I work for GE as a principal technologist in the architecture department. I've been with GE probably around about 20 years in the infrastructure space. I've been doing a little bit of application stuff, enterprise architecture, and probably for the last 12 months I've been writing cookbooks and really trying to drive DevOps and kind of agile methods of continuous delivery in GE Capital.
Hi, my name is Rick Mary. I've been at GE Capital for about 9 years now. I've worked on lots of apps, frameworks, a bunch of different language platforms, and I'm hoping that we're going to tell you and show you something really cool today. And if not, you get to just watch me have a nervous breakdown, right? So if I'm you, it's a win-win.
I'm John Morrow. I work at Chef for the last 4 years or so across a couple different organizations. I've been focused on building continuous delivery pipelines. And for really the last year, I've had the privilege of working on these guys' pipeline with them and helping them deliver delightful within GE.
So you're probably thinking, GE Capital, that's not a typical chef customer. They've got a lot of background in manufacturing. They're famous for things like Six Sigma. So that kind of has been true for a while. But we started looking at what's going on in the marketplace, and we're seeing a lot of competition coming from internet startups who are really able to bring new financial products to market very quickly. And we kind of need to try and do the same, but we've got a lot of stuff that's delivered traditionally. We're running in probably 90 plus data centers. We've got thousands of developers, hundreds of sysadmins. We operate in a lot of different time zones, and something that some of these startups don't have is we have a lot of regulation from people like the Federal Reserve who actually sit in our offices and kind of scrutinise everything that we do. So we were challenged by the business to try and start delivering faster, but also to simplify stuff and do consolidation. So what that really means is that we needed to take a look at how we actually create the space to deliver things faster, business functionality faster. And what we saw is that we're actually spending a lot of time keeping the lights on. So we're doing things like the patching, security stuff. We've got all this simplification stuff going on with reducing the data center footprints. We've got a lot of stuff coming in for regulatory compliance. So these are things like the visas and the MasterCards and the stuff from the Fed, where we actually have to make application changes specifically for them. And this is not really value-add stuff that we can actually sell to customers. And so if you kind of look at the arrow, the actual percentage of time that we can spend on real stuff of value to the business is actually quite small. So to create the space, we started looking at how we actually deliver stuff, and the methods that we have been using up to for recent time. Pretty archaic, so we're still doing a lot of manual deployment. We are doing automated testing, but we're not fully covered with automated testing. So we need a lot of input from the business to say the things look right, and that's really driving the change management people and the governance people to be quite risk averse. So if we want to deploy any application, typically we've got like 3 months or 6 months release cycles. lots of features being crammed into those release cycles because they happen so infrequently. And so we're always asked, to produce an implementation plan, a backup plan, risk assessments, that show we've covered every single risk and we've got some kind of mitigant for it, and that takes a lot of time and effort. And even then, we quite often will end up having to back out for some, small reason, backing a lot of work out. So the other side of this is really the governance side. So we've got the security guys and the legal guys who've all got to take a look at what we're developing. And so they have their own process, and we'll take a look at this slide. So typically when we're doing these 3-month or 6-month sprints, we've got a lot of toll gates. So if any of you are familiar with like Prince2 methodologies, you do a little bit of work, you come to a toll gate and you produce a bunch of documents, and there's quite a lot of documents in some cases. You do some work, you do that little piece of work, you produce some stuff at the end, and people kind of review it and decide whether you can move on. Now, that's not really scalable when we actually start wanting to introduce agile development and DevOps, because we're not delivering anymore in 3 to 6 months, we're delivering 1 or 2 week sprints. And if we're running a lot of applications through that that process, you'd need an army of governance people to deal with that. So what we're trying to do is kind of slim down that governance process. So we're not actually saying we kind of ignore what's got to be done, but we try and produce a lot of the documentation automatically and the metrics automatically, and make it very transparent what we're doing. Which I think Justin talked about the whale sausage this morning. But we need to let them see how the sausage is made. So we invite them to all of the demos, and that enables us really to make sure that they can feed back their concerns into the planning for the next sprint, and that really helps build trust with those guys, so that they're not so afraid of us, kind of delivering this stuff, and they feel comfortable that if the auditors come in and want to see what we've been doing, that they can do. So I'm going to hand it over to Rick now to just talk a little bit about continuous delivery, because maybe not everybody's familiar with continuous delivery.
Thanks, Rich. Can you guys hear me okay?
Yep.
So, I've been thinking a lot about this slide, and I look at it and I go, it's so hard to just lead in with it, right? Because I could stand here and I can give you the Wikipedia definition of what continuous delivery is, right? But I mean, at show of hands, how many people know what it is? Heard of it? Okay. How many software developers are in the room? Apps, infrastructure. Cool. So you guys probably have an appreciation for something like this, right? It's easy to see why it's so important to test and automate. I can remember times when, developing software meant I was sitting at my desk, I'd build a WAR file or whatever, and I would copy it manually over to a server and restart and hope everything went fine. And then continuous integration came along, and we had tools that helped us take it to that next level, so that we were at least integrating everyone's changes and continually running unit tests, and that was really good. And that was the next step in the evolution, right? And so when continuous deployment came along, and we just had that ability to just blast the thing across to all of our environments, we said, geez, does it get any better than this? And well, yeah, continuous delivery came along and said, well, it's the same thing as continuous deploy, but you have that ship it button, right? Which lets us put the brakes on things, or at least gate what we want to do when we want to do it. So, continuous deploy, very, very cool, the right thing to do. Everybody agrees on that stuff, right? But, it's not enough. Right? I think we found in our experience that we were paying a lot of attention to the app tier, right? We said, geez, we're really good at building up a Java Spring app into a WAR file, and SCPing the file over, and SSHing and saying, Tomcat stop. You know, clear the temp and work directory, Tomcat start. Look, my app came up, that's great, I'm done. I am the hero, I'm the man. Well, until, okay, let me ask you another question. Have you ever heard this or have you ever experienced this? It works great on my system. You know where I'm going with this, right? Very, very common, right? So why does that ever happen, right? Well, we know the answers, right? It's because we have inconsistencies across our environment, right? And so, you know, what do you do about that? I mean, as a Java developer, I've seen things like this before. You know, I build my WAR file using JDK7 locally, right? Works great. I'm using like JDK7_51 or something like that. And you know, it works in dev, it works in QA, works great. Everyone's going to love me for this. I'm going to push it to prod. Push it to prod, it blows up. Why? Well, you know, I get this nasty little error, unsupported version error or something like that. And I go, geez, you know, what is that? I'm using JDK7 everywhere. What's the problem? Well, I am, but I'm not, right? I'm using a minor version that might be less than what I'm using in my local development environment. And maybe they came out with this new thing that I tried to take advantage of, but it wasn't really there. And so anyway, problem, right? And so, you know, things like that happen all the time, right? Our infrastructure gets out of sync, and we need to solve this problem, right? So, continuous convergence, right? We have this ability now with infrastructure as code. There's no reason why we shouldn't be putting our infrastructure code through the same rigors and through the same testing disciplines as we are with our applications. I mean, why not? It's code, right? We can write tests against it. We can deploy it. So why not, right? And you know, on the surface, I go, geez, remember before I was saying it doesn't get any better? Well, I think it just got better, right? And you know, and that's great. So, you know, just imagine you have lots of infrastructure and you're putting everything through its own pipeline, and you're putting your apps through their own pipeline, and you're saying, geez, all my environments are consistent, and this is the greatest thing ever. Now I know that I won't get into that scenario where it worked locally and it didn't work on prod. This is, thank you for this, right? But it's not enough, right? We're almost there. We're almost there, but we're not 100% there, right? The real answer is you have to have your infrastructure pipeline and your application pipeline come together at an environment where you can perform all of your testing on both together. And we have that. And this is what we step back. We got with Chef. I mean, these guys have been. It's been. And a team of 21 of us, we just went nuts on this thing. We said, we're going to do this, and we're going to make it delightful, and we did. And so the bottom line is that you get to this magical place called Union, right? And everything comes together, and you run all of your testing. And if everything goes well, you move to the right, you move into rehearsal, you move into production. And now, the thing that you're guaranteed at this point is that the application the infrastructure that your application depends on promotes with it all the way down the pipeline. This is something that it's just a game changer, I think. So this is where we find ourselves. It's exciting times. I'm gonna hand it over to John and let him dive down a little bit deeper into it.
Let me take you through the pipeline and kind of the shape that we developed to support this. And as Rick talked about, we have multiple pipelines, and you can think of these as any of the vectors for change in your infrastructure. We want a pipeline that monitors a code base, because now we are actually able to put all change for all of our infrastructure in code. And each of those has its own pipeline that comes through. And you can see that with these kind of two parallel paths on the left side of this. But that's not quite good enough. They have to come together, and the delivery coming out of those parallel pieces has to be tied together So we ensure that our infrastructure goes with the applications. When they join in union, this has an interesting consequence on the system. It means all changes in our infrastructure, and for us this is kind of around a failure domain. It means all the changes for that failure domain are now tied and delivered together. It's kind of a powerful statement. It changes the way that you think about it. In the past, we thought of shipping a single application, and that went through. But that's not good enough. If this application depends on a database or depends on a web tier being in it, we have to test all of that together, and it means we have to ship it all together. And that's the point of these pipelines coming together in union. So early in the pipeline, this doesn't look all that different than a standard kind of gated trunk process. Anybody that's done software development is now at the point of doing this. You know, you check your code out, you work on a feature branch. We're able to run some quality metrics against it locally. In our case, we're able to run Test Kitchen because our whole infrastructure is described with Chef. We can stand up the app locally with Test Kitchen and test it. Or if it's just something like a Postgres database, we can do the same thing with that. On submitting a change, we come into a CI system, and we rerun we do a hypothetical merge with master, make sure that if any new changes have been contributed to our master branch, our delivery branch, that we test this change with those. Make sure we're not breaking the existing environment. We do that by rerunning a bunch of metrics against it. And for us, we're using Garrett as the way that we orchestrate or the way that we report all of this data back. So on each of these, upon success, we always get a check mark back in Garrett. If that all goes well, now it's time to have a human look at this change. We want to make sure that this code, for all of the things that you can't do in an automated fashion, we want to make sure this code's good. And if it is, we go ahead and forward it for final approval. And this is an interesting question in our process. This final approval, not final approval, this approval at this stage is really the development team asking, is this change fit for production? When we go on master, we want to believe that this will be a good change for production. If we can't make that statement, we need to go back to the beginning and figure it out, fix that change until we can make that statement. So that process happens in Garrett for us. And if we go ahead and approve that, Garrett's going to automatically merge it with master. And now we hit something we call the release stage. This is where we actually produce all the artifacts. We first want to rerun our unit and syntax and our lint phases. So for Java cookbooks, this is like JUnit. For actual chef code, this is things like Food Critic, Chef Spec, and all the usual suspects that you're used to using to ensure your code quality. At the time that we're shipping something to production, we also have to do some extra stuff. And for us, we created this idea of a place in the pipeline, a known place to do security and quality. This is where we produce some of those documents that feed our compliance process, our governance process. They happen on every potential release. And this is what's allowed us to have a conversation with the governance team about changing the way that we do these things. We need to produce all the artifacts, and in this case, because we're tying all change together, producing the artifacts for us means producing things like the WARs. It's also the cookbooks. It could be data bags that drive those cookbooks. It's ultimately version pinning, so we're sure we're using the versions of stuff we just released when we ultimately converge an environment. We have to upload all of those. So the WAR goes to Nexus, all the Chef stuff goes to Chef server. And then we need to pre-bake our next environment so that when we converge that, it's got pointers to all that stuff we just built. And we do that by setting some environment attributes and setting some pinnings for the cookbook versions that are going to be in effect. And we trigger what we call the acceptance stage. Now this is what a lot of people would call dev. It's the first real environment that you go to. But we don't call it that because we have a lot higher confidence in our code when we hit this point because of everything we've done to the left. So really what we're doing here is making sure that the code stands up, it'll start up, it's good, and it's a place to kind of take a look at it and make sure in kind of the non-describable functional requirements, make sure that it passes all of those things.
So really, this is kind of a point where you actually created release candidates. It's very early on in the process.
Yeah, and for us, we don't mark it as a release candidate. We actually mark it with the released version. We'll throw it away later if it's not good, but it comes out of this with an actual production-bound version number. It's also another place for this governance by demo, because this is where we do our iteration demos. And we're able to do these demos as often as we need to satisfy the governance team. So if this all passes and everything's good, then we move on to this idea of being able to choose to ship the code. And this is the last kind of manual interaction point. I'd say if you have any really long-running manual processes in your org, as you look at implementing CD, if you haven't done it yet, this is a good spot to do it. It's where you can run UAT because the environment exists and it can exist over a longer period of time. It's also where you might do some performance testing. So we get to this idea of shipping code. And for us, this is now the place where we're saying, is this fit from a business perspective? Maybe I've got a feature flag turned off, or maybe I've implemented some new hot thing, but because of marketing reasons, we're not ready to have this in production. It can sit here in acceptance. New changes can come in behind it, and we'll just sit and batch them up. And when we're ready to ship it, we go ahead and hit the shipping button. Business is happy, we go ahead. Specifically, we're going to take all of the attributes from this application's acceptance environment and all the cookbook pinnings and move them into union. And then we trigger the union stage. Now, union is the first place where everything's come together. It's where we can test that we don't break things that depend on us. So, in this world, if you think about Rick's Java example, if my application came into union and it didn't stand up, or I got that class error that you talked about, the pipeline stops. I haven't screwed up production, it's still working. I can ship a change to Java on the infrastructure pipeline. It lands in and updates its version within union. So now we've got two changes in union. And if we pass all our tests, now we'll go ahead and move that forward. That's been really, really powerful to make sure that we're not breaking our real environment. We go ahead when union is happy and promote into rehearsal. Functionally, the steps we do are exactly the same. Take all the pinnings and attributes from union, move them into rehearsal. And if that's all good, trigger production. And again, it's the same steps. One of the things you may have noticed about this is that everything after we hit the ship it button was automatic. If we pass union and rehearsal, you can't stop it rolling. And it's because the way we think about union, rehearsal, and production, they are all production. They are all about assuring that when we go to production, that will be a successful deployment. The other thing that some people ask me when they look at this is, why rehearsal then? What's it doing for you? And if we think about union being broken because of something like Java, it could be the case that the reason the next change comes in and makes union successful is dependent on the broken state. So this makes sure that in rehearsal now, we can test it from no and good. And it turns out that what we needed, you could get in this argument of, well, then I need rehearsal and rehearsal star, because rehearsal's broken, well, then I need another one to do that. What it turns out is that because of the idempotence of chef, what you need to test is that you can go from broken to good and good to good. And by having two, we're able to assert that on every deployment. So it doesn't matter the state of production. We know what we're going to ship there. If it works in the previous environment, should take that environment to be working. So this was a huge change for GE. When I walked in a year ago, they had some of the kind of standard CD that Rick had talked about. And it's taken about a year for us to get here, of working on this pretty in-depthly. And through that process of taking the organization from kind of single parts of your stack CD to this idea of full stack CD, we learned quite a bit, and I think Richard will come up and talk a bit about that.
I guess the first thing that we learned is that really everything's got to be in source control. So that's all of your database schemas, your application code, your infrastructure code, even your tests. So you might actually have tests, for a version of the application which are only for that version, and a new set of tests for your new version. So you've got to be able to take all of this stuff through the pipeline in sync. And also the source control really is part of your audit trail, so you need to know what's actually being changed and who changed it. Second thing is that we need to remember this principle of do the smallest thing that's actually going to satisfy the requirement. So if you've actually been working in an environment where you're delivering sort of 3 or 6 month releases, everybody is going to want to cram everything they possibly can into the next set of changes, because they don't really understand that we're going to run these things, every couple of weeks potentially, and you'll find a lot of people actually bringing conflicting requirements as well. So you need to make sure that everything is codable. So in your organisation, you may actually find you've got a lot of standards and things about how you build servers and how you write code and all those things. You have to actually be able to make code from that. So if you have something that says we need to have a legal banner, you need to actually know what has to be in that legal banner so that you can actually write a test to check whether it's there. And if you do get some of these conflicting requirements and you've got to code it, and you've got to fit it in a sprint, you've got to empower the team to actually decide, when you've got some conflicting requirements, which one's actually going to win. Because if you actually leave it to the people who are fighting about what should be there, you're never actually going to finish your sprint. And we ran into quite a lot of that as we first started doing this kind of activity. You need to give your developers the tools to be able to do the job. So, give them the machines that they need to actually be able to spin up environments locally. Spin multiple VMs, run the tool, like Test Kitchen, all the compile things, all that kind of stuff. And the last thing is really DevOps is not always for everyone. So some of your your sysadmins or even some of your developers may not actually want to learn new stuff like Git. It's quite a complex thing, got quite a steep learning curve, and a lot of the time these people can actually stay in the roles that they're in right now, because you're not going to move everything day one from the way that you maybe do things now into the more sort of agile and DevOps styles. So when you're actually investing all this effort in actually bringing these people up to speed with DevOps and Agile, you're actually going to be spending a lot of your own time teaching these guys, and this is going to run into weeks. So if you're going to invest that amount of effort, you don't really want these guys then kind of leaving and not doing anything with it and forgetting how to do it. And eventually, you're probably going to bring these guys back, but when you actually got a bigger kind of pool of people who know how to do this well. And so because of that, kind of shortage of people who can do that, we're actually finding it's quite hard to, to find people from outside who know how to do this. So if you're kind of interested in a job with us, we are hiring. So does anybody have any questions about what we've talked through?
I got one. It
So
seems like, go ahead, that the long pole right now is still testing. And they've got a process that gets it to the rehearsal stage or something like that. But, until you address test coverage or something like that, you still have a manual process and they make sure that it works. Is that the case for long pole?
Yeah, I mean,
The whole process of the long pole is still verifying, but doing the manual piece of testing.
Yeah, absolutely. And if you want to achieve the kinds of velocities that lead you to delivering multiple times a day, there is an investment in testing. It's a significant, when we go into a new business unit, so we kind of come from global kind of central GE capital, and we're moving this out into all of the sub-business units. When we go in, we spend an entire day teaching people TDD, which is not something you would think about when you go in to say, I'm going to teach you how to do chef, and I'm going to talk about this pipeline thing we built, and I'm going to make your life good. No, we make it a first-class investment in the process up front.
Yeah, testing is the basis of all of it, right? I mean, test. If you can get as much coverage as you can possibly, 100% if you can get it.
How do you catch up? Because you're not going into greenfield applications, right? You're going into existing applications.
Yeah, that's a good question.
Yeah, so you kind of end up with a bunch of quadrants of kind of capabilities. So you can say I'm going to do the testing stuff for the infrastructure and use this this kind of methodology to make sure that at least you've got consistent environments, and then maybe you can start by adding maybe UI tests, just to kind of kind of smoke test your application when you deploy it onto a new platform, and when you push changes through on your infrastructure, you can get a reasonable degree of confidence that you haven't broken the app. But really you have to start pushing for to get your unit tests and functional tests into the applications as well. But you can go with partial testing, but you lose things by not having that full testing.
But I think regardless of if you do this thing we're talking about right here, right now, I think you need that test anyway. You need all that testing rigor, no matter which direction you go with any of this stuff.
Yeah, I mean, you have a certain risk profile, even with manual testing, that you're choosing to accept. And we all know the fastest way to get something through an automated pipeline is to turn all your tests off. But you adjust your risk profile in a way you're maybe not comfortable with if you do that.
So there's another question.
So who actually contributes to cookbooks? For example, you have new application version and new configurations. Who actually changed cookbook to template this new configuration? Developer or DevOps guys?
So there's multiple levels. The underlying infrastructure stuff, and we work in a very open model where anybody can check out the code and work on it. But by going through this rigor, we can make sure that what they check in is good. So we have like a product owner for Java. And that person would accept all of the contributions to that. Every application also ships with its own chef cookbook in the root of the source code. So the specific code for deploying that app ships with it. I think you were front row was first.
Sure. Did you use any tool to do the pipeline orchestration on it?
Yeah, so we wrote a custom in-house tool. GE wrote a custom in-house tool.
And then are you using that for all applications or just for that entire process, or for one or two just?
Well, as it matures and we move forward with it and it becomes more and more capable, our hope is that we'll move as many as we can into that. In a perfect world, everything would be in there. I mean, because you know, when you think about the way it works, it does make a lot of sense, right? Not yet.
So I think we have time for one more. There was one like mid-row. Yeah, go ahead.
Do you cut images or containers at the end of rehearsal, or do you keep everything stood up?
Currently, we keep everything stood up. But I can imagine a world where you would consider doing that. And like that's an optimization. But you have to be able to do it in existing real hardware in a big organization because people have it. So we haven't hit a point where the pipeline's slowed down enough that we really need to invest the time in that yet. So again, thank you guys for attending.